permutation, order does matter, which is why you're going to always get a larger number of permutations than combinations. Okay, because if it did matter that I shook Cole's hand or Cole shook my hand, we would count that 2 different counts. But it doesn't really matter. It's one handshake. We both shook each other's hands. So it counts as 1, and that's what makes it a combination. So a combination is an arrangement of objects in which order is not important, which is different than permutations where order is important. So that's the biggest way to remember the difference between the two. Order does matter for permutation. Combination order does not matter. Which is kind of hard because when you think about a combination lock, it does matter which numbers you put in first, right? So that's kind of, they should call them permutation locks. Let's start the movement, okay? Permutation locks, not combination locks. Because it's really a permutation of those codes. It is a combination of numbers, but when you put it in there, it does matter about the order you put them in. Right? All right, so here is your formula. So remember our permutation was n factorial all over n minus r factorial. Well, to get the combination to a smaller number, we need to take away those repeated combinations. So we need to take away Cole, Mrs. Crowley, Cole. We need to combine that into just 1 count instead of 2 counts. We're going to end up having to divide out an extra r factorial. So this is your permutation formula. To make it into a combination, you have to do an extra dividing out of r factorial. Okay, because if you think about it, if we had 5 people, if we were doing a permutation, then me to Cole, me to Ben, me to Jason, me to Brandon, and whoever, me to Mac, I think that's 6, would count that many ways, and then the converse of those would all count as another set of those. So I need to take out that doubling factor and divide out that extra r factorial. Okay? So remember, n stands for the number of items in whatever your trial is or whatever it is you're looking for. R represents the specific amount. So 6 choose 2, 4 choose 2, 2 choose 2, 15 choose 3. All right, you ready to make it work? Here we go. Making some juice. Anybody have a juicer at home?
Yeah.
What kind of juices, what kind of fruits do you put into your juice? You never used it?
No.
All right. So in this case, we're not juicing anything, I guess. We're going to purchase 3 different kinds of juice. We're walking through the grocery store. There's 10 different juices up there on that shelf. And we want to pick 3 juices to take home for Christmas dinner.
So, apple.
Thanksgiving's first.
Huh?
We're already done into Christmas.
I did. So, let's say we got apple, orange, grape, banana juice. I never really ate banana, but pineapple, tomato juice.
Tomato is definitely not a fruit.
Has seeds in it.
Cucumber is a vegetable.
That's like saying a cucumber is a fruit. That has seeds in it.
Cranberry juice. All right, so all these juices are up on the counter, or the shelf. Okay, guys, come back. Out of those 10, does it care if I picked apple, grape, and pineapple in that order? Would that change what I walk out of the store with, whether I did pineapple, apple, and then grape? No. So even though the order is different, it's still me walking out with those 3 juices. So that's why it would be a combination as opposed to a permutation. So we have how many total items? 10, so that's our n. So we're going to do 10 combination 3. So let's set up our formula. What goes in the numerator? 10 factorial all over r factorial, which is 3, times, what's my n minus r?
10 minus 3.
So 7 factorial. All right, let's see what things we can eliminate. Yes.
How can you just sort out the long way?
What do you mean the long way? Oh, you like just
Find
do?
10.
Sure, if you want to do it that way. So if we try to eliminate things, what would get knocked off from the 10 if I divided out the 7 factorial? 7 and below. So I would have left in my numerator 10, 11, or why am I going up? 10, 9, and 8, right? Because 7 would go away, 7 through 1. All over, and then 3 factorial, which is just 3 times 2 times 1. I don't really need the 1. So what does that get us? 10 times 9 times 8 is 720. 3 times 2 is 6. Divide it, and we get 120 different ways we could purchase those juices. Which reminds me, anybody do the bonus? The 5,040 permutations?
I forgot at the house.
You forgot at the house? Sure. Okay. All right, we're good there? All right, what if, here's the green team committee. We've got to choose 3 of the 5 nominees for the committee. I don't know why Mary Curie's bigger. I guess they really want you to vote for her. We got Isaac Newton, Albert Einstein, Niels Bohr, and Charles Darwin. So if I'm making it a committee, does it matter who gets picked first?
No. Yes.
No.
No. Like, because if I just went and I circled these 3 people because they were the first, would it matter if I did Albert Einstein, then Isaac Newton, and then Marie Curie, or the other way? No, it does not matter because I'm just picking a committee. So this would be what? Notation. 5 combination 3. Which gets us what? 5 factorial divided by 3 factorial times 2 factorial. Now be careful, yeah.
Does it matter which one, like, we get rid of, like, the 2 or 3? Does it matter, or does it have to be the one that's in parentheses?
Because this is, in parentheses, is the n minus r. So I guess I should be showing that step. It's really 5 minus 3 factorial to get to the 2. Is that what you mean? Oh, which one comes? No, not because community property multiplication allows you to. Right, no. Sorry, I wasn't understanding your question. So 3 factorial, 2 factorial. So what's going to cancel out from the 5? 3 and under, so we're just going to be left with 5 and 4. All over 2 factorial, which is 2 times 1. So 5 times 4 is 20 divided by 2, which gets you 10 different ways, 10 different combinations. Now, if we put these guys into positions, if we said we want a president, a vice president, and a secretary, then what would change? It would go to a permutation, right? And what would I get rid of in my formula here? I would get rid of the 3 factorial. So really, that would go to what? What would cancel from the 5? Everything beyond 2, so it would just be 5 times 4 times 3. So 60. Okay, would be the permutations of the ordered matter. All right, last one. How many different ways are there to purchase 2 CDs, 3 cassettes? Do you guys even own cassettes anymore?
Yeah.
Got some cassettes? Any videotapes?
Yeah.
Yeah, you guys got VCRs at home?
Yeah. I think it's broken.
Might be broken. All right, so we're walking on the street, and Blue Moose has this giant cardboard box on the sidewalk, and it says, everything in here, $1 each. And you're like, yes. Like, I really wanted 2 CDs, I really wanted 3 cassettes, and I really wanted 1 videotape. That's what you're just hoping for. So in the box, there are 7 total CDs, there are 5 total cassettes, and there are 3 total videotapes to choose from. So I want to know how many different ways can I purchase those CDs, cassettes, and videotapes. Well, so we need to figure out each individual combination. So let's just focus on CDs. How many total CDs are there? 7. So I'm going to do a 7 combination. How many do I want? 2. Now let's go to cassettes. What would that look like? 5 combination 3. And then my videotapes would be
3 combination 1.
3 combination 1, right? All right. See if you can figure out what each of those numbers are on your own. See if you got it. Because my 5 factorial would take away everything 5 and below. This is 7 times 6 times 5 times 4 times 3 times 2 times 1. Right? Are you sure? And then 5 factorial is 5 times 4 times 3 times 2 times 1. So that 5, 4, 3, 2, 1 would cancel, and I would just be left with a 7 and a 6. And then 2 factorial, which is 2 times 1, which is 2. Yeah.
So if the 5 was the 2, and the 2 was the 5, would you still take away the 5?
The 5, yeah, go with the larger number. Yep. So check yours with mine. So the 3 numbers that I'm getting. You guys getting there? All right, so what will we do with those 3 numbers? We're not going to add them. We're going to use the fundamental principle of probability, which is you multiply all 3 of those together. So we're going to do a 21 times 10 times 3. So what is that? 30 times 21... 630. So that means I can stand outside of Bull Moose and I can stand there for 2 hours and figure out all 630 combinations that I can make with my CDs until I found the perfect one, and I could go home a happy person. Right?
Yeah.
Yeah. All right, so combinations, permutations, questions with any of that? All right, so